I picked up a couple of these battery chargers in Lidl because I thought they were quite good. They do 6 volt, they do motorcycle batteries, which is presumably a small 12 volt battery, and a car battery, and also they've got a cold setting for a car battery as well, so in very cold conditions the voltage is different and it just adjusts the voltage ratings output and fully charged. So this thing senses when the battery, lead acid batteries these are charged, and then adjusts the voltage accordingly to trickle charge your battery. And it says in the instructions it's safe to keep it connected, and in fact my emergency battery I use for starting people's cars when they come round has been on charge with one of these for a long time, and just trickling it up, and it hasn't boiled it dry. It's been quite good. But daughter dearest left her lights on, and I thought, oh, I'll go and charge her battery up for her, connect the battery charger. No joy. It just blinked error and went back off. Every time you tried to turn it on, turned it off, turned itself off. So then I tried the connections. I thought, well, it must be the connections. But then I realised there's a major design flaw with these chargers. Is that when your battery's flat, it'll charge up a slightly discharged 12 volt battery, but the voltages at which it kicks in and detects it's 12 volts are almost the voltages where the car will start anyway. So as an emergency charger to charge a flat battery, it's absolutely no good at all. And I've got a setup here. I've just been fiddling around with it because I thought, well, I'll modify it, and then I thought, well, I'll just put the video up in case anybody else wants to modify theirs. So here we have it. It's a nice unit. It's waterproof. It's got a seal in it. It's all waterproof and sealed, and these I've had it apart already just to have a poke around inside actually. And these are all O-ring sealed, so the thing, in theory you could get it very wet and it wouldn't affect it at all. So I think the build quality is very good for a Chinese product. You know, the clips are quite nice. They're very grippy, very clippy, and considering it's only a 4 or 5 amp charger, they're very good clips actually, and the cable's nice, and the cable's a good length. So everything about it is good, except that when you have a flat battery that won't start your car on a 12 volt car, it will not recover that situation. You need to get an old-fashioned battery charger that just pumps power or current into the battery to bring the voltage up. But as soon as this detects that the battery voltage is less than about 10 volts, it can't decide whether it's a 6 or 12 volt battery, therefore it won't charge it. So that interim area where the lights have gone really dim and you can't quite start the car and there's some power left in the battery, this thing won't recover the situation. Now I don't, do I? No, I don't. I don't have any 6 volt batteries. So what we're going to do is have a look at maybe modifying this unit so it's actually useful, so that if you do connect it to a flat battery on your car, it will actually charge it, rather than say, well, I can't decide this is a 12 volt, I can't decide this is a 6 volt, so I'll do nothing. I mean, in that situation it should bung in a few amps, you know, for maybe 10 minutes or something like that, and check the current again. You know, just a little bit of intelligence would sort this out. But I have got another battery, a 15 amp battery charger from China, solid state one with switch mode, and it's exactly the same. So it seems to be a common thread going through several models. I don't know if they're all made in the same factory or designed for the same person, or one person wrote the code and then someone else stole it and distributed it to all the clone manufacturers. But yeah, it's not a lot of use. So I can just demonstrate this to you now. One minute, I'll just set up the camera and I'll demonstrate. Okay, so now this unit here is a electronic programmable load, and what it does, it allows you to set a constant voltage or a constant current. It allows you to vary those parameters, and it's for testing power supplies. For example, if you wanted to load test a power supply to see how good the output regulation was, i.e. if you draw some current, how much the voltage changes, you can do it on this, and it's got a DC computer interface, electronic interface on the back, so you can connect it to your computer. It's what I use for checking my power supply designs for grow lights, high power grow lights. And on this side is just basically, really you can think of this as the battery. If I set that to turn that down, you can think, oh, it's now the battery is discharged to 10 volts. Oh no, the battery is charged to 9 volts. So you left the lights on all night and your car battery's gone down to 5.6 volts, which is nearly totally flat. Okay, so by varying this, I can simulate the voltage of the battery, a 12 volt car battery, and on this side I can set the load at which it starts conducting. So if I set it in constant voltage mode, which it is, it's going to try and keep the voltage at a certain level, and if the current feeding in this tries to rise, it'll actually conduct more power and keep the voltage set to 12 volts or whatever I set it to. So as soon as it's a 12 volt car battery, we're in constant voltage mode, and look, if I turn that, I can set the set point 12.02. so let's just set it to 12 volts. Okay, so now that's set to 12 volts, this will keep the voltage, stop the voltage rising. So if the battery charger starts to try and charge, it'll start conducting the power as if it's charging the battery. So this is simulating the charging side of the battery, and this is simulating the flat battery voltage. Okay, and both of these are connected together. These two sets of leads here, these ones, come from here, and they're connected together, and they're both connected to the battery charger, or at least they will be in a moment. So that's that black one on to the black clamp, that red one, then a red one, and somewhere here, oh yeah, there is another red one. Okay, so let's put that on there. Right, so they're both connected. Right, so at the moment, let's say, okay, we've got a flat 6 volt DC battery, and then we'll set the voltage here down to 6 volts. Okay, so that's pretending to be a 6 volt battery. If I try and charge a 6 volt battery, the current will appear in this meter here. So if I go back to the old jobby down here and turn the power on, I don't know if you can see those LEDs very well, but at the moment it's just that one LED is on. Can you see it? If I press the button, it's refusing to do anything. Can you see that? It just goes back to square one. It won't do it. Okay, so let's turn this voltage up to 5 volts and then press the button, and now it's flashing error. So it's doing something different again. It's check battery connections. Can you see those flashing? I'm going to turn the lights off for a second. Hold on. And there you can see them flashing clearly, can't you? So if I zoom in a bit, you might be able to get a better idea of this actually. Okay, that might be helpful. Can you see it now? Yes, you can. You can see it flickering there. So there you go. Got all the lights flashing. Oh, now it's gone to 6 volts. So now at 6 volts, it's detecting it's got a 6 volt battery charge, and you can see here, look, the current, this is limiting it to 6.076 volts, and there's nearly 1 amp, 0.79 amps going into it thinking it's a battery. Okay, so that's your 6 volt setting. So I turn that off now. Now if we go up to make this into a 12 volt battery, so this is your car now, we're talking about a 12 volt normal car with a 12 volt battery, and there we go, 12 volts, and then I turn this voltage up to, this is the flat battery voltage here going up on my finger on this side, and I turn it up to, say your battery is just charged to 9 volts, so it's not totally flat, but you've only got 9 volts left in your car battery. When you turn this on, show you, if I cover that, I might be able to say, there you go, I'm getting battery error. Okay, so this won't, even though my car battery is 9 volts, this is saying error. I can't decide if that's a 6 volt or a 9 volt or 12 volt, therefore I'm not going to charge you at all. I mean, that's absolutely useless because you can't recover a flat battery on your car. Okay, let's turn that off and turn this voltage up a bit more, up to, let's just try 10 volts. So now your battery's okay, 30-40% discharged. It would probably maybe just turn over a car at 10 volts, but the current supplying capacity to crank the engine wouldn't be very good. But let's try it now, look, watch this. Still error. So it won't charge your 12 volt car battery if you're down to 10 volts. Okay, so okay, let's try again. Let's try 10.5 volts. So my car battery is now at 10.5. It's just slightly fat, needs to top up. Will it charge it? will it buggery? Look at that. What use is that as a car battery? You know, it'll only charge your car battery if it's not really flat. Totally flat, you've left the lights on like numpty, you've got no chance. Okay, so let's try 10.8 volts. Turn it off. Now it's charging, look. It's gone to motorcycle mode, and you can see we've got 12 volts on the output now. It's jumped to 12 because it's now providing power to charge your battery, and we've got 0.8 amps going into your battery. Okay, and if I hit it again into car mode, it's gone over, so I need to go into 30 amp mode. Alright, stop moaning. Yeah, it's gone in this funny mode, this thing does. Constant voltage 30 amp and the output is off, so turn the output on and now do it. Yeah, there we go. So yeah, so that's your motorcycle. Where we were just testing car, weren't we? Look, now we've got 3.8 amps going in. So you've got 3.8 amps up here on this display, the lower green display. That's the power that would be charging the battery. That's being absorbed by this electronic load at the moment, and the voltage is 12.07. You can see if I turn the voltage up as well, you'll see the characteristics, because a fully charged car battery is 13.6 volts after it's just been charged. You can see it's charging with 13.4. So even though it's a 12 volt battery, it's still pumping in 4 amps. You can see it's going 12.68, it's gone to 3 amps, and then you can see it's reducing the current, which is what it should do. Now it's switched down, look. So if I turn that back down, will it come back up? No, it won't. Once it's got to that threshold, it stays there until it's charged. So let's turn it up. 14 volts, 14.3, 14.5 nearly. Then you see it's changed to 5 milliamps. So this is your trickle charge. This is your maintenance charge, which will just basically roughly equivalent to the self-discharge current of the battery. So you won't hydrolyze all the acid in your battery into hydrogen and oxygen and make it possibly explode or boil dry. It'll just cook nicely and keep it well topped up at 14.47 volts. So 14.5 volts is correct. So just to recap what we've done there, we've just proved that this will, if your car battery has discharged to below 11 volts, slightly flat, this won't recover your battery. And if your battery is too low, it won't recover your battery. You can see now the full lights come on. Right? So I'm going to modify this to make this useful and do what I want it to do, which is to properly charge a 12 volt battery. Even if it's completely flat, I want it to pump that 3 or 4 amps in my car battery to get it up into the charging range where it will recover the battery. So let's have a look at that and see how we might go about it. I have to open the unit up, I'll do that now, and then we'll have a look inside. There you go, so here's what's inside. It's quite a nice circuit board. It's the old compressed cardboard paper rather than the fiberglass circuit board, which is not such high quality, but it's good enough for this. Are we still recording? Yeah, we are. Right, okay, so what have we got? We've got an input choke, we've got a fuse, input choke. There's 2 input chokes, an input choke, filter capacitor, and then a differential common mode rejection choke. And then mounted on here is the switching transistor, high voltage DC, the rectified mains smoothing capacitor, and a couple of class Y capacitors to connect both the main side and the low voltage side. Small reservoir capacitor for the bootstrap voltage to power the control chip, and on the back we've got a simple control chip circuit which is just producing. So this is really just basically a DC power supply, this section here. Quite a good one actually. There's the bridge rectifier. So there's a lot of components in there. It looks like it's been designed properly, and if you look here, this is a separation between mains and the connections that you can access as a consumer. So you don't want to be connecting to the mains, you don't want to be any referencing to the mains at all, certainly within any notable current, otherwise you get an electric shock if the voltage is high. So the only thing connecting these 2 sides together are 2 class Y capacitors in series, which is good. They're very high voltage capacitors, so it's just to stop this getting too charged up and too much noise across. And this opto isolator, so this is a small electronic circuit with a couple of photo transistors, or 1 photo transistor and a photo receiver, and as it suggests, the light produced on one side is shone across a barrier and affects the other side. So by this means you can feed back your voltage. There's a comparator circuit here which tells this to switch on and off to keep the voltage, the DC voltage on this side within limits, the voltage you're looking for in the design. Okay, so separation is good. So you've got a nice big gap there, and it's supposed to be 2 kV separation, so that looks good to me, well designed. There's your little push button, look, that's the multifunction push button, that thing there. Little tack switch, little domed tap switch. Various bits of tracking have been beefed up. You've left the etch off and allowed the solder. This has been flow soldered under here. So these components are first glued on and then soldered, as is common with most hybrid boards. This is a hybrid technology because you've got through components and you've got surface mount on the other side. So on this side you have got a reservoir capacitor, a couple of reservoir capacitors, an output choke, a relay presumably to connect and disconnect the battery, that relay, and then on this side you've got the control electronics. Okay, so all of this, all of that area does, switches the LEDs on and off and controls takes the input from the button, reads the voltage back from the battery, converts that into a digital number representing the battery voltage through what we call an analog to digital converter, probably in the micro, and then there's a management code in there which manages this and controls the charge and what have you. So what we want to do is to fool this processor. We can't change the code obviously, so I reckon what we should do is just fool this processor into thinking that we've got, or I've got, an 11 volt battery connected. An 11 volt battery. Okay, so it would automatically default to charging a 12 volt battery as soon as I connect it. So if my car battery is dropped below 11 volts, I can still connect this and it will go and say, oh, there's a 12 volt battery charging connected, I'm going to charge it. Because at the moment it's hopeless. You have to get out your old-fashioned power supply, which I've had for years. It's just got, a very crude transformer. It's got no regulation as such. It's just a transformer in a box to get the battery going up to above 11 volts before this can take over. So it's a real fag. So I'm going to see if I can con this into believing we've got a 12 volt battery connected, even though it's not detecting more than 11 volts, which is the normal criteria it uses. We've proved that already. Okay. So let's have a look at that. Right, okay, what we've got in there, I had a poke around, is a input to the microprocessor, and there's the sensing input there, and then coming from the actual car battery, it's the this is the car battery, 12 volt lead acid. It comes in through the crocodile clip. That's a crocodile clip. I know it doesn't look like much, but use your imagination. I'll put it there. And it comes into the unit and it goes through a resistor, through another resistor, and this is the microprocessor and the whole system. What volts? 0 volts. 0 volts. Roots. And yeah, so this is a sense input, and it just goes to there. It just goes to there. And so our problem is that this requires a voltage on here which is sensing 11 volts or greater. So greater than 11 volts. Smiley. Less than 11 volts. No good. Okay, smiley, no good. So we've got to make it fool it into thinking that there's a battery that's got more than 11 volts into it to kick it into 12 volt charging mode. So on the other side of this processor is a plus 5 volt rail, and that is a regulated 5 volts. That's quite accurate. And I've wound the input voltage up and down quite a bit, and doesn't vary much, if at all. So what I've done is I've wired in a circuit, a very simple circuit, but still nevertheless cunning. So from the 5-volt rail, what I've done is taken a resistor and another resistor to make a potential divider, so we can pick a voltage off here. So remember, this is 5 volts, and I've sort of designed it so the current going down there equals about 3 milliamps. Okay, so there's 3 milliamps going down here to ground, and that will generate a certain voltage across these resistors depending on their values according to the normal potential divider law. It's all over the internet if you want to see it. And what we don't want to do is, when this battery voltage starts to climb and it's charging and it's doing its own thing, this is quite a high impedance in here. These are hundreds of K, these resistors, and if we leave this circuit connected, it's going to affect the actual voltage of the cell. So that in effect what will happen is the microprocessor will no longer be able to tell, oh, what's going on, what's voltage. It'll be having contribution voltage from here. So I did try it with just a diode in, like that, a blocking diode, and then I connected that blocking diode all the way around to this point here. And then the theory was that when this voltage started to rise above where this was feeding in, then this diode would block the current coming down here when its reverse voltage was dropped below 0.7 volts. So I designed this to be about 1.7 volts. Here, this point here, 1.7 volts. Drop it through the diode, it'll go down to 1.1. But the diode was leaking enough current, even at when the forward voltage was 0.3 and it should have cut off. The diode was still leaking enough voltage down here to raise this voltage and give a false reading to the microprocessor, and it was cutting off about 13.8 volts rather than the 14.5. So it's having an effect. So in the end I decided to cut my losses, and actually it's a better system is to put a switch, a push button switch, and connect it down to this point. Okay, so now when you've got the other switch on the microprocessor, which is the mode switch, this one, mode, that's the button you cycle through the different charging. So if you want to force this into, say, hey guys, you've got 12 volt battery and I want you to kick 12 volts mode, want you to be in 12 volt, you just hold the press button switch and then click this switch until the high charge, and then you can release that, and then it's into its charging cycle and it will carry on pumping out the 3.8 volt amps at 12 volts or thereabouts until the battery's charged. And when it's running, there's no effect because there's now open circuit. So now the sensing circuit isn't loaded by our potential divider, any leakage current in this diode, and it'll basically go back to, unless that button is pressed when you first start up, this will be under standard functionality as the designer designed it. So I've wired this push button switch in, I've wired these resistors in. In fact, to fine tune this to be correct, I had to use 2 resistors because I couldn't find a combination or a single combination of single resistor values with the standard values. So I put that is only in there just to fine tune this circuit, and also across there I put a electrolytic capacitor, 10 microfarad, just to filter out any noise coming in from this digital supply here into the analog circuit. I don't know whether that capacitor was needed, but it's good practice, and that one was 10 microfarads. And it's got to be greater than 5 volts really. Okay, so the value of these resistors, we have this one, resistor 1, resistor 2 and resistor 3. Resistor 1 is R1 equals 1k ohm, R2 equals 510 ohms, and R3 is, how much is R3? Let's have a quick look, can't quite remember. Yep, it's a 56k. 56k. And the diode 1 is an IN4148, just a basically ordinary silicon planar diode, nothing special, signaling diode. So yeah, so if you want to do this modification, you need these 4 components. Okay, that's what you need to do this, and it works. I've just tried it. I'll show you in a bit, but there you go. So I'll just cut to the close-up and I'll show you how I've wired it in. Right, here's the unit. A word on safety if you are going to do this. I don't suppose anybody will ever see this, but I've got 2 of these chargers and they're very good, but they just needed a bit of TLC and a bit of common sense injected. If you run this thing with the cover off, look, this is mains, which is horrible mains. Then it's rectified, and then across this component down here there's going to be about 360 volts at UK mains voltages. So this half of the board can really spoil your day. You know, you don't want to be mucking about with this. And this component, which is the capacitor under there, as most of you know about capacitors, I'm sure, can store a bit of charge. It has got 2 270k resistors across it to discharge it, so I don't think it will hold charge very long. So you know, if you are going to open it up, A, make sure you know what you're doing and you're aware of the safety risk, and B, wait 10 minutes after you've plugged it in, after it's last plugged in, to open it up and do the modification. Okay, you do this mod at your own risk, but don't touch this, don't plug it in outside the case unless you really do know what you're doing, and you're doing it at your own risk. Okay, so yeah, anyway, going over to here, I'm going to see if I can zoom that in a bit further. One moment. Okay, so what have we got? We've got the wires. That's what we've got. We've got these wires here. We've got the this is the microprocessor next to the red button switch. This is the micro. That's the button you press to get everything to happen. Obviously this thing is not plugged in at the moment. Taking a black wire off the 0-volt rail, which is across this decoupling capacitor. Black wire going up through that hole next to it. I've taken a red wire off the other end of the capacitor through up there, and obviously you're making very fine connections, so don't short anything out, but this looks like that is shorted to that, but the 0 volts on that pin there, pin number 1 of this IC, are actually on the same track, so that bead of solder doesn't matter. In fact, there was no extra resist on the board, so the solder flowed across. So black wire to the 0 volt rail, pin 1 on this capacitor, and the red wire 5 volt rail going upstairs. Okay, so I'll show you what I've done on the other side of the board in a second. So that's our 5 volt supply for our potential divider. And then here, on the end of this resistor, which is the 510 ohm resistor, next to where it says R57. Okay, so it's the R57 end of the 51k ohm resistor, 510 and 2 zeros, 51k. Okay. So that's our wire where we're injecting our sense voltage to fool the unit into thinking we're running at 12 volts, because we are very cunning like that. Right, so now I'm going to flip her over. One moment, I'll flip it over, but I'm going to stop the film and get it into focus. Okay, so here's our, onto the board I've put a blob of epoxy and stuck it on 3 resistors, R1, R2 and R3, which you saw in the circuit earlier. So this is our 1k resistor. This is our 68k resistor, and under there is the 510 ohms. Okay, so this is R2, R3 and R1. Right, you can see all 3 resistors are joined at one end, which is where our voltage is generated. Our phantom voltage is going to be present to fool the processor. Okay, so there's the capacitor, 10 round the right way, ground at this end, positive at this end. That's that 10 microfarad capacitor, just to provide some smoothing and decoupling. Alright, and then these are epoxied onto the board. So I'll just zoom out so you can get that into context where it is on the board. Here we go. There you go, that's how it looks like. And what I'm going to do is put this back in the case and then drill a hole and have this poking out the case so I can press the button when I need to go to 12 volt high charge mode to recover my flat battery, otherwise you can't charge it. So yeah, I'm going to put it back together. Actually, I can demonstrate it working to you now, actually, probably. No, I'll put it back together first and then we'll just show it working. The unit's back together. You can see the components down here. You can see a switch, a sealed push button switch, push to make, momentary, that I've mounted in the side part here by the cable outlet. It's unlikely to get knocked or broken off because this will protect it. This part will protect the switch button. And yeah, so now if you have a car that's slightly discharged or not quite 11 volts, you can now hold this button down, switch the unit on, and then go straight to the 12 volt charging mode. And what was a useless piece of kit which wouldn't get you out of trouble, now a useful battery charger. So it's a shame that they haven't really considered this. It's beyond belief that they would design something that's so stupid, but you know, what can you say? Lidl sold it. It's no good. So anyway, I'm going to put it back together, put the case back on, and then the final thing we'll do is just a quick demonstration test so you can see it working. Okay, so soon. Okie dokie, it's fully assembled. Got the button on the side, as we said. There, and yeah, so up here, look, you've got, actually I can just turn this off, this is not doing anything, but the voltage and the current is 0, the output is off, so there's no voltage being presented to the system at all. So as far as battery charger is concerned, there is a dead flat battery. So, and I press this button, so again, just to reiterate, nothing happens. If I put the voltage on to say 5 volt or 8 volts, 9 volts, your lights are dim, it won't turn over properly. Battery error, still won't do anything. It's bloody impossible, isn't it? So okay, so your battery's flat. So now if I turn this off completely, for example, I've checked this quite thoroughly, it works fine. So I turn this off, turn the output off, no battery, 0 volts, battery's connected, the load is there, but that is set to 12 volts. Look, see? So this will start conducting power, and this is pretending to be a battery. This is sinking the charging current into the tester there. So if I just hold a little button, my new little button in, ready, and there we are. You can see that. You can see that we're in car charging mode. We've got up in the current indicator here, the green one, 3.88 amps flowing, and it's 12 volts. And if I just increase the program voltage, so the battery's charging up, the voltage go up 12.04, 12.05, let's go a bit faster, 12.1, 12.2, 12.3, 12.5, 12.6, still charging, still 3.8 amps. Now it'll detect that the battery's almost charged, so 13.6, still charging, the current is falling slightly, 13.7, 13.8, 13.9, and there you go, it's gone to 14. Now it's gone to trickle charge to top your battery up, so it's dropped the charge down, otherwise it will produce a lot of hydrogen and oxygen, lots of hydrolysis going on with the acid. So it'll deplete your acid, not good for the battery. So now we've dropped to 0.79 amps, and then we go up and up, and the terminal voltage is approaching, and there we go, still keeping it at 0.8 amps, and then bam, yeah, 14.4 volts, the fully charged light comes on. Can you see that? Can you see that? Let's turn that off so you can see. Oh, there you go. Alright. So yeah, I've got my emergency start button. Makes this into a useless brick that won't charge your battery if it's flat, into a handy little charger. But yeah, touch of a button. And of course, without the button pressing, it's still got standard functionality. So it'll still do the 6 volt and the motorcycle batteries. So only when you're in a jam, you can press that and then you can start charging, rather than thinking, what am I going to do now? I've just paid 15 quid on a battery, ultimate speed battery from Lidl, battery charger from Lidl, should I say, and you're stuffed. So anyway, that's the mod. I hope you found that interesting. I've got 2 of these, I'm going to do the other one as well, and yeah, useful little chargers now. Okay, thanks for watching.